So today we're going to be working with something a little bit different. We're going to be starting a new topic, which is dealing with inductive reasoning and deductive reasoning. So again, they're both based on two different ideas, and they're also based on different ways of thinking about math. So for the next couple of lessons, that's what we're going to be working with. Actual types of reasonings, right? So we have something called inductive reasoning, and they're not difficult at all. It's just, again, different ways of thinking about things. We have something called inductive reasoning, and then we have something called deductive, right, with the D. We have deductive reasoning. And again, they're both reasoning, so they're both ways of thinking about things, but it's just different ways about thinking or being able to analyze information. So when it comes to inductive reasoning, it's reasoning that's based on observations, right? Reasoning based on observations. So again, it's what you see. So it's never guaranteed. So what I mean by reasoning based on observations is, if you look out the window today, it's raining. If it rained yesterday, if it rained the day before, if it rained the day before that, based on inductive reasoning, based on your observations, you can say that tomorrow it's going to rain. And that's what inductive reasoning is. It's when you start making conclusions based on what you see, based on the observations that you're making, based on things that you think is going to happen. Again, that's all inductive reasoning is. It's reasoning based on observations, what you think is going to happen. Whereas deductive reasoning, and that's the one that gets used most of the time when it comes to like science and math and things like that, it's reasoning based on facts, right? Based on facts. So when it comes to deductive reasoning, it's not what we think. Deductive reasoning is what you know. You know for a fact that it's going to happen. Whereas inductive reasoning, it's almost a guess as to what you think is going to happen. So when it comes to inductive reasoning, you think it's going to happen. When it comes to deductive reasoning, you know for sure it's going to happen. So out of these two, deductive reasoning is the one that's most guaranteed. It's sure because it's facts, it's the truth. Inductive reasoning is what you think is going to happen. So like if I gave you guys a quiz yesterday, you got an A. If I gave you guys a quiz last week, you got an A. If I gave you guys a quiz the week before, you got an A. Most likely, based on inductive reasoning, you think you're going to get an A. That's what inductive reasoning is. It's what you think is going to happen based on what you see, right? Whereas deductive reasoning, again, it's facts. You know it's going to happen because there's the truth. There's no debate about it. And when it comes to inductive reasoning, and that's the one that we're going to be working with more, just because going forward, we're going to be working with deductive reasoning all the time. And almost everything you always do in a class, for the most part, is always deductive reasoning because it's based on facts. So when you solve equations, that's deductive reasoning because you're solving equations based on facts, you know what I mean? But when it comes to inductive reasoning, we have these things called conjectures, right? And all a conjecture is, it's just a statement. It's just a statement based on inductive reasoning, right? Based on inductive reasoning. And what I mean by that is, if you were to say that last week I ate cereal for breakfast, this week I ate cereal for breakfast, based on inductive reasoning, I can make a conjecture saying that next week I'm probably going to eat cereal again. And again, it's not a guarantee, but a conjecture is just a statement as to what you think is going to happen. If again, it's sunny yesterday, it's sunny today, based on inductive reasoning, I can make the conjecture that it's going to be sunny tomorrow. That's all a conjecture is. It's just a statement based on what you think is going to happen. You know what I mean? Again, it's not facts, but it's what you think is going to happen. That's what a conjecture is. And so when it comes to inductive reasoning, why learn about this? And again, it's just different ways of thinking about things. So like if I were to give you something like this, right? If I were to give you this pattern, say that's 4, that's 7, that's 10, that's 13, right? If I wanted you guys to figure out what are the next 2 numbers, let's say, right? We'd be using inductive reasoning. because we're trying to figure out what's going to come next based on what's going on and using logic, you know what I mean? Making observations, drawing conclusions, right? So now if we look at it, if we see that it's going from 4 to 7, right? So from 4 to 7, what's happening? It's literally changing. Let me use a different color. It's changing plus 3, right? And then if I look at 7 to 10, we start to make the observation, right? That again, it's plus 3. And now if we see 10 to 13, we see again, plus 3. So now we've drawn a conclusion. We can make an observation that we know what's going to happen, right? Or we think we're seeing what's happening. So from 4 to 7, it was plus 3. From 7 to 10, it was plus 3. From 10 to 13, it was plus 3. So from 13 to here, it's going to be plus 3, right? So now it's 13 plus 3 is going to end up giving us 16, right? And then 16 plus 3 is going to end up giving us 19. Again, that's what I'm talking about inductive reasoning. You're drawing conclusions based on what you're seeing, guys. Again, just patterns. Whenever you're filling out patterns, that's inductive reasoning. Now let me give you guys another one just to see if you guys can actually see it. If you have something like this where we have, let's say we have 5, we then have 3, and then we have 4, and then we have 2, and then we have 3, and then we have 1. What number would come next, right? And so now if you're looking at that, right? Start noticing things, and sometimes a lot of times people try to add and subtract and all that just because they assume that that's what it's going to be. And again, you're just looking for patterns when it comes to this. You're trying to make observations. You use an inductive reasoning. And if we look at it, going from 5 to 3, a lot of times, again, we'll think this way. It went minus 2, right? And then from 3 to 4, it went plus 1. From 4 to 2, it went minus 2. From 2 to 3, it went plus 1. From 3 to 1, it went minus 2. So we've seen the pattern. We see the observation that we're making. We're seeing that it goes from minus 2, plus 1, minus 2, plus 1, minus 2. So over here, based on an observation, we know that it's going to be plus 1, right? Which would end up making 1 plus 1 be 2. Again, all just examples of inductive reasoning, guys. Just trying to figure out what's going to happen based on observations. So we can say, so this is what a conjecture is also. Basically saying we know, based on all previous observations, we can say that the next number would be previous plus 1. And we can make a conjecture saying the next number would be 2 minus 2, right? That's what a conjecture is. It's just a statement, something you're saying, right? And now based on all this, again, there's 3 properties I need to show you guys just to make sure that you get it. And it's dealing with something else that I don't know if you guys have learned already in elementary school. We have 3 properties. We have something called the symmetric property, right? We have something called the symmetric property. We have another one called the reflexive property. And we had then another one called the transitive property. And the last one's called the transitive property. And again, these are all 3 properties. I don't know if you guys have ever heard of them or not, but it's good to know what they are. And the best way to actually show you what they all are is through examples. So what the symmetric property is let's say that I were to have AX. What the symmetric property says that AX is going to become XA, right? All the symmetric property is, it's the same thing, but you just flip them around, right? So if you have AX, it becomes XA, you flip them around. If you were to have, let's say, TMF, it would become FMT. That's what that property is. Symmetric property, it's the exact same thing, you just flip them around. You literally just flip them around. The reflexive is the easiest one to remember because the reflexive literally says that whatever you have stays exactly the same. Nothing changes, right? So if it's TM, it's going to be TM. And they're equal because it's saying that TM is equal to itself, right? Reflexive property, whatever it is, stays exactly the same. And reflexive, because think of almost like a mirror, staying the same. What you see is what you have, right? So reflexive stays exactly the same. Symmetric flips. And then the transitive is when it compares three things, right? So if it's saying, let's say, if A equals, if A equals B, right? And B equals C. So if A equals B and B equals C, we then know that A equals C, right? And it's just saying that. It's if this is the same as this, right? If these two are the same, and now these two are the same, if you get rid of what's in the middle, you know that they're all the same, so these two are also the same. That's all that means. If A is the same as B, and B is the same as C, then we know that A and C are the same because they're all the same. Transitive property basically means that all of the terms that you're comparing, they're all the same. So if they're all the same, the first one and the last one are also the same. Again, that's the one sometimes people have issues with. But it's like saying, if I'm the same height as John, and John's the same height as Mike, then I'm the same height as Mike, because we're all the same height. That's transitive property. Reflexive again, everything stays exactly the same. And then symmetric means whatever you have, you flip it over. That's symmetric property, guys. Again, just remember, when it comes to inductive reasoning and deductive reasoning, inductive reasoning is based on observations, things that you see. Deductive reasoning is based on facts, right? So again, inductive reasoning, you think it's going to happen, but you don't know for sure. Deductive reasoning, you know for sure it's going to happen. So again, all that, just keep those in mind. Take care, guys.